Square root. Welcome to Mark's Math Methods. Square root. 5 times 5 is 25. Negative 5 times negative 5 is also 25. What is / are the square roots of 25? I use the is are and the s at the end of root, so I don't give you any hints as to whether there's only one or more. So let's start the clock. 5 and negative 5. But then what about this question? Root 25. That's 5 only. So what's the difference? When I use the words square root or the symbol, the radical sign, what is the difference? Well, the words want all roots. So that's going to be positive or negative if they exist. The radical sign or symbol with an even index, notice I flashed up there 2, 4, 6, 8, only wants the principal root. Principal means positive. So when you use the symbol with an even index, that little green number there, it wants the positive root only. So when I say the square roots of 36, that's 6 and negative 6. But when I use the symbol root 36, it only wants 6. Some things you just need to memorize. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, all the way up to 20 squared is 400. And the reverse. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. All the way up to the square root of 400 is 20. Because these numbers keep coming up. If you have to stop every second to pull out your calculator and do these, it's going to slow you down. You're going to lose focus of where you are in the problem. So the best thing to do is to write it out and put it on your fridge. Because every time you go open the refrigerator door, you're going to see the numbers. And you're going to start to recognize these special numbers. But let's use a calculator. Square root of 529. Root 529. That's 23. That was easy. Root 1600. 40. Those were nice perfect squares. How about some that aren't so perfect? Such as square root 75, round to the nearest tenth. Now some calculators will give it to you in root form, reduced root form, but we're doing decimals. We want to round to the nearest tenth. So root 75 is 8.660254, and it continues on. Rounding to the nearest tenth gives us 8.7. Round to the nearest thousandth, 106, root 160. So we plug that in the calculator. We get 12.649110, and it continues. And rounding to the nearest thousandth is 12.649. Round to 3 decimal places. Sometimes they'll give you the number of decimal places they want you to round to, as opposed to giving the place value, tenth, thousandth, hundredth. So we plug it in the calculator, and we get 10.0995046. 3 decimal places, which is the second 9. The 5 to the, wait a minute. Yeah, there we go. 10.100. Because those decimal places did exist and we did round, we do have to add those zeros, We can't just write 10.1. Okay, we have to write 10.100 because those values existed and we rounded through them. Can we do it with decimals too? Root 1089, root 10.89? Sure, 3.3. 0.0016. That's 0.04. Those were nice numbers though. How about some that aren't nice? Some not so perfect. Round to the nearest hundredth, 7.5. Well, 2.738612 and so on. Right into the nearest hundredth is 2.74. Round to the nearest thousandth, 1.01488915 becomes 1.015. Let's do some root work without a calculator. 0.04. What? Oh, wait a minute. I can write 0.04 as 4 over 100, which now gives me root 4 over root 10, which is, or root 4 over root 100, which is 2 over 10, which is 0.2. Hey. Now let's fill in the missing values. We're estimating a root value. So root 39, it's between what and what? Root 39 is between what and what? Well, what are the perfect squares on either side of 39? Well, that would be 36 and 49. 36 is less than 39, and 49 is greater than 39. They're the roots on either side. So when we take those roots, we get 6 and 7. So root 39 is between 6 and 7. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.